So, when it comes to oscillations, okay, ang naituro sa inyo sa Physics 101 ay yung harmonic oscillator, right? Okay, and in general, tawag dito, any object can undergo oscillation. And yung harmonic oscillation is just an approximation. In fact, if you remember, the differential equation or the equation of motion is actually proportional to sine theta, pero ang ginagawa ninyo is you approximate sine theta equal to theta using the Taylor series expansion, right? So, of course, gusto natin na as much as possible i-relax yung approximation na yun. But, you can only do so much in terms of mathematics para maging as accurate as possible, di ba? To mimic yung actual behavior ng nature. So, what we usually do is to approximate is to do a Taylor series expansion, di ba? So let's start with a Taylor series expansion of the force, which is a function of x. And using Taylor series expansion, we get this x times df x naught evaluated at x naught. So this is 1 over 2 factorial x squared, and then d squared f dx squared evaluated at x naught. Okay, plus 1/3, 1 over 3 factorial x cubed, and then third derivative ng f with respect to x squared evaluated at x cubed, sorry, with respect to x evaluated at x naught, and so on and so forth. Okay. Now, we know na yung potential na ito is related dun sa gradient, and we also know that the gradient is must be referred always to some reference position. Okay, so it needs a reference position. And oftentimes, sineset natin na yung reference position na yun to be 0. Which means na in the terms of force, we can also set this to 0. Okay, para lang ma-simplify yung discussion. Okay, so that takes care of the first term. Now let's take a look at this second term. Now yung second term, x times df dx evaluated at x naught is somewhat, well, we can equate it to minus kx, di ba? Kasi yun yung first approximation natin before, which is yung spring, yung force due to, or force acting on a spring, di ba? And from here, okay, if we equate in dalawang equation and we see that the spring constant is actually related to the first derivative of the force with respect to x evaluated at some position. Okay, and we know this. Okay, of course, we know this to be Hooke's law. And from Hooke's law, we say that the spring constant is just the first derivative of the force with respect to the position evaluated at the reference position, or at the equilibrium position. Okay, so that takes care of the second term. Okay, now for the higher order terms, okay, well, this would depend on a specific system. Okay, pero for our purposes at this time, hindi natin muna gagalawin yung mga higher order terms na yan kasi nga tulad ng sinabi ko, it will depend on some specific system, and those systems we're not going to tackle in this discussion in this chapter. Okay, so let's begin with what you know, which is yung simple harmonic oscillator. Okay, so from simple harmonic oscillator, Okay, when we sum the forces along the x-axis, okay, we say that the force experienced by the object, okay, that is connected to a spring is equal to negative kx. Okay, so, and that is the net force. Okay, so this is from Newton's second law of motion. Okay, so mx double dot is equal to minus kx, so which we can rewrite as mx double dot plus kx equals 0. And oftentimes, sinasabi natin na omega squared is equal to k over m. Okay, of course, yung k dito is spring constant, yung m is the mass. And this becomes the angular frequency squared, di ba? Omega naught is the angular frequency. Okay, so x double dot is equal to or plus k over mx is equal to x double dot plus omega naught squared x is equal to 0. And we know kung ano yung solution dito. Okay, ang alam natin na solution dito is x is equal to a sine omega naught t minus delta, or x is equal to a cosine omega naught t minus phi, na kung saan yung difference between delta and phi is just 90 degrees. Okay. Okay, alam natin yun from mathematics dahil yung phase difference between the sine and cosine is 90 degrees, right? Okay, so if we use this cosine, okay, this equation for for x, okay, okay, what do we get? Okay, what do we get? Let's say we're solving for the kinetic energy. So ang kinetic energy ng system undergoing simple harmonic motion, of an object undergoing simple harmonic motion, okay, is just 1/2 mv squared, or ngayon gagamitin nating notation is x dot squared, which means kukunin natin yung derivative ng x. Ano bang derivative ng x? So if x is equal to a cosine omega naught t minus delta, okay, delta na lang gamitin natin. Okay, so x dot will be equal to a negative sine a omega naught sine omega naught t minus delta. Sorry, ganito ang gawin natin. Wag cosine gamitin natin kundi sine. Oops. Hindi ko na siya mabubura. Wag yan ang gamitin natin. Gamitin natin ay sine. So x is equal to a sine omega naught t minus delta, which means ng x dot is equal to negative or positive a omega naught cosine omega naught t minus delta. Okay, so that means this will give us a squared omega naught squared cosine squared omega naught t minus delta. Okay, and we know that omega naught squared is equal to k over m. So m omega naught squared is equal to k. Okay, meron tayo nitong m omega naught squared dito. So papalitan natin yan ng k. So 1/2 k a squared cosine squared omega naught t minus delta. Okay, and yan yung ating ngayong expression for the kinetic energy. Okay, what about for the potential energy? Alam natin na for potential energy, yung expression is 1/2 kx squared. And since we're using x equals sine omega naught t, so we have 1/2 k a squared sine squared omega naught t minus delta. Okay, and if we get the total mechanical energy, so equals t plus u, this will give us okay, 1/2 ka squared cosine squared omega naught t minus delta plus 1/2 ka squared sine squared omega naught t minus delta, or since yung cosine squared plus sine squared will just be equal to 1, we'll have is equal to 1/2 ka squared. Okay, notice na yung derivative ng E with respect to time is 0, which means that the energy is conserved. Okay. Okay. So from here, we get all these different parameters. Of course, yung isa pang parameter na kino-consider nyo before is that yung omega naught is just 2 pi f. So we can say na for omega naught squared is just 4 pi squared. F squared is equal to k over m, or f is equal to 1 over 2 pi square root ng k over m. So, yan yung mga equations na kino-consider natin pagdating sa simple harmonic motion. Okay, and from here, we can also get the period. Okay, it's just unfortunate na ang ginagamit na kinetic energy is capital T, so we'll use tau not to indicate yung period nung oscillation. Okay. Okay, now for a simple pendulum, if you recall, okay, yung equation of motion is actually doesn't have actually that form. Okay, so ang equation of motion for a simple pendulum is theta dot plus omega naught squared sine theta is equal to 0. Okay. Okay, and anong ginagawa natin dito para mas mapadali yung pag-solve? Okay. Ginagawa natin, we use a small angle approximation where we expand sine theta using Taylor series and approximate it equal to theta, and then theta dot is equal to, will be then equal to, or this equation of motion will be then reduced to theta double dot omega naught squared theta is equal to 0, which is, of course, very similar dun sa ginawa na natin kaninang solution. Okay. So yan yung para sa simple pendulum. Now with the with numerical techniques, you can actually determine kung ano yung solution using sine theta, okay, without having to deal with the approximation. And you can say na for angles less than 10 degrees, okay, yung difference between this approximate solution, okay, and this more realistic solution, okay, is the same, pero for angles greater than 10 degrees, then makikita natin na yung real solution starts to deviate as a function of time. So mas magiging obvious na yung yung difference between the real solution and the tawag dito, and the approximate solution. Okay, any questions so far? Okay, so most of this, or all of this ay na-discuss na natin sa ano, di ba? Or na-discuss niyo sa 101. Okay, okay. Now let's consider harmonic oscillations in 2 dimensions. In 2D. Okay, which means we consider forces acting along the x-axis at saka forces acting along the y-axis. Okay, so along the x-axis we have negative kx. Okay, and if we use spherical coordinates, then this will be kr cosine theta. And along the y-axis, this is negative ky. Then in spherical coordinates, this is kr sine theta. Okay, yung equations of motion using Newton's second law, equations of motion natin ngayon will be x double dot plus omega naught squared x is equal to 0 along the x-axis, and y double dot plus omega naught squared y is equal to 0. That's along the y-axis. And of course, yung omega naught squared is equal to k over m. Now we have two solutions here. So x is equal to a cosine omega naught t minus alpha. And then y is equal to b cosine omega naught t minus beta. Okay. So, of course, yung alpha and beta will be different for both of them. But syempre, gusto natin makakuha ng solution na na compact and maybe independent of time. Gusto natin tanggalin yung omega naught t, or yung time dependence. So we'll do some mathematical trick. Okay, and oops. Okay, and we begin with, syempre, sulat muna natin yung x of t. So x of t is equal to a cosine omega naught t minus alpha, and y of t is equal to a cosine, b cosine omega naught t minus beta. Okay, so starting from y of t, we get b cosine omega naught t minus alpha. Okay, and let's just write this for now, plus alpha minus beta. Okay, sulit lang muna natin yan. And then this will give us b cosine, okay, omega naught t minus alpha sine alpha minus beta, okay, minus b sine omega naught t minus alpha cosine alpha minus beta. Okay, and then if we let delta be equal to alpha minus beta. Okay, and also alam natin na ang cosine, itong cosine omega naught t na term na to is just x over a. So this is x over a. Okay, this gives us so x over a times b sine alpha minus beta equal to sa B, or so minus B, sorry, minus B. And since sine is equal to the square root of 1 minus cosine squared theta, then this becomes square root of 1 minus x squared over a squared times cosine alpha minus beta. Okay. So naintindihan niyo kung paano lumitaw yung x squared over a squared? If you didn't, just let me know dun sa chat box. Okay, so yan yung ating y. So we can simplify this, multiply everything by a. Okay, so we have a y minus, and then yung i-move natin to sa kabilang side, bx sine alpha minus beta is equal to, if we multiply this by a, no? Is equal to ab square root of 1 minus x squared. Okay, pero kung may a squared kasi denominator, di syempre magka-cancel na yung with the a. So pwede na natin tanggalin to. Okay, times cosine alpha minus beta. Wait, tama ba itong ginagawa ko? Mukhang hindi tama yung ginagawa ko. At hindi nyo ako kinokorek. So this is cosine, this is sine. Of course. So this is cosine, and this is sine. Okay. By the way, papalitan natin yung delta ng alpha minus beta. So ay minus bx cosine delta is equal to b square root ng 1 minus x squared sine delta. Okay. Gusto natin tanggalin yung square root na yan. Oops. A squared dapat ito. Gusto natin tanggalin yung square root na yan. So we square everything. Okay, and when we do that, we get a squared y squared minus 2a bxy cosine delta plus b squared x squared cosine squared delta is equal to a squared b squared sine squared delta minus b squared x squared sine squared delta. We can simplify this, okay, further. So okay. Notice na ito at saka ito ay pwede i-simplified. So they just reduce to a squared b squared. Okay, so we get b squared x squared. So we get a squared y squared plus b x squared. B squared x squared minus 2abxy cosine delta is equal to a squared b squared sine squared delta. Okay. Okay, so we'll work with this equation. Now, we set delta equal to pi over 2. Okay, and when we do that, plus or minus pi over 2. When we do that, ano ang cosine ng pi over 2? Ang cosine ng pi over 2 is 0. Tama? And ang sine ng pi over 2 is 1. Okay, so we are left with a squared y squared plus b squared x squared. Okay, this term becomes 0, and then equal na lang to sa a squared b squared. Okay, and we can also simplify that further to be equal to x squared over a squared plus y squared over b squared equal to 1. Okay, and what is this reduced to? Okay, so this is an equation of a circle. Equation for a circle. So if we assume further na a is equal to b, then we have x squared plus y squared is equal to 1. Okay, yung circle na yan is anong tawag dito? Has a radius of 1. Okay. So in other words, pag pinlot natin ang graph na to, x versus y, so x versus y, then we just simply get a circle. Okay. What if we set delta equal to 0, for example? Okay, if we set delta equal to 0, then cosine delta is 1, and then sine delta is 0. So this term here becomes 0. And we are left with a squared y squared plus b squared x squared minus 2ab or equals to 2ab xy. Okay, or hindi, sige, minus 2ab xy is equal to 0. Okay, which is nothing but a or bx minus ay quantity squared, right? Is equal to 0. So which means na y is equal to b over a times x. And if we set a equal to b, then y is equal to x. And what is this? This is just an equation of a line. Okay, so if we graph that x versus y, then we get this line. Okay. So how do we interpret itong graphs na ito? So remember, this is x versus y. So this is displacement. Okay, so along the x-axis, ito yung displacement, di ba? Along the x-axis. So it just moves from here to here. And along the y-axis, yung displacement moves from here to here. Pero if you combine both displacement, then you will see na yung kung ano man yung nag-oscillate has this motion. Okay, so if it's a pendulum, okay, if it's a pendulum, imagine niyo na ito yung pendulum. Okay, and this is the xy plane. And then ito yung pendulum. That pendulum will trace a circular path along the xy plane if ito yung conditions na binigay natin sa kanya. Okay, delta, remember, delta is equal to alpha minus beta. And alpha minus beta. And alpha is the solution to the phase lag dun sa x and the phase lag dun sa b. Okay. So, yan yung makukuha natin na motion niya. And what if delta is equal to 0? In other words, yung alpha na ito, at saka yung beta na ito is the same. Okay? Ang lalabas na motion nila is just a straight line. So again, if you're considering a pendulum, okay, and then ito yung xy plane, okay, that pendulum will just move in a straight line path. Pag ganyan lang siya. Okay. Pag ganun lang. Okay. Now, you can vary, of course, yung delta. Okay, and of course, it's easy to set A tsaka B. Diba? You get this different types of trajectories, okay, for various phase angles. Okay, and then, of course, this is for A equals B. Okay, and depending on the phase difference between alpha and beta, you can get these different kinds of trajectories along the x-axis. If we consider the angular frequencies that aren't equal, if these are not equal, okay, and they are they are fractions of each other. Okay, so makakuha tayo nung tinatawag na Lissajous curves. So notice na you get these Lissajous curves, okay, for yung angular, ito yung case na kung saan yung angular frequency along the y-axis is twice the angular frequency sa x-axis. Okay, and yung phase difference between them is 0. Okay, dito naman yung phase difference is pi over 3. Okay, kita nyo doon. And then dito yung phase difference is pi over 2. Okay, so ganyan yung trajectories ng object, okay, undergoing simple harmonic motion in two dimension. Let's go back to, to the displacement along the x-axis. Okay, x of t is equal to a sine omega naught t minus delta. And if you take yung first derivative niyan with respect to time, we get a omega naught cosine omega naught t minus delta. So we can write x over a to be equal to sine omega naught t minus delta, and x dot over a omega naught be equal to cosine omega naught t minus delta. And if we square that and add them together, then of course yung sine squared plus cosine squared will just be equal to 1. So we have x squared over a squared is equal to, or plus x dot squared over a squared omega naught squared is just equal to 1. Okay, now of course you would say, oh, mukha tong equation ng Lissajous, or equation as circle, di ba? Katulad kanina. Pero kanina, we considered yung displacement along the x tsaka displacement along the y. Here, ang kino-consider natin is displacement along the x tsaka velocity along the x. Of course, yung shape ng graph nito is still a circle. So this is still a circle. Pero yung coordinates dito ay x, at dito ay velocity along the x, speed along the x. So if you have this type of graph where you are plotting the velocity with respect to ang tawag dito, to position, okay, this is called a phase diagram or a phase portrait in phase space. Okay, so this is a phase diagram or phase portrait. Okay, so what you're trying to do here is to describe yung motion ng velocity with respect to position. Okay, okay, let's see. Alam natin also na alam natin before na derive natin before na ang 1/2 Ka squared ay equals to total energy, di ba? Okay, and of course, this is also equal to 1/2 m omega naught squared a squared, since k is just equal to m omega naught squared. K is just equal to m omega naught squared. Okay, so in other words, if I consider this and I consider this, then I can write itong equation ito as x squared over 2e over k plus x dot squared equal to 1/2 e or 2e over m. Okay, equals 1. Okay, now we are describing the phase space in terms of the total energy of the oscillator. Okay, so this. Okay, so anong ina-expect natin dito? Well, of course, we expect na hindi magko-cross ng paths yung trajectory ng dito sa phase space. Okay, bakit? Kasi each energy is unique. Okay, each eigenvalue is unique. Sorry, each energy is unique. Energy nung particle given a specific position tsaka velocity. And if each energy is unique, then hindi sila pwedeng mag-cross ng paths dun sa phase space. Okay, so ano bang itsura ng phase space na yan? Then, well, since mukha siya equation ng circle, in general, hindi siya circle talaga, kundi an ellipse. Okay? So this is the phase diagram for a simple harmonic oscillator for different energies. So yung nasa loob, yan yung smaller energies, and yung nasa labas, yan yung higher energies. So this is this is the graph of x squared 2e over k plus x dot squared 2e over m equals 1. Okay, and they're not necessarily, it's not necessarily a circle because m and k are different. Okay, so ang paano natin i-interpret yung motion dito? So as the object moves, okay, from left to right, so here yung velocity niya is 0. As it is moving towards the equilibrium position, the velocity is maximum. And then as it moves towards the other end, the velocity again is 0. And then as it goes back, the velocity is again maximum, pero since it's negative, then it's in the opposite direction. Okay, and then as it goes back here, the position goes back here, okay, nagiging 0 ulit, which is exactly how we understand simple harmonic motion to be, right? And each plot dito, each circle dito corresponds to a different energy. Okay, so in some sense, this is how we use yung phase plot. Okay, and it's actually a very powerful tool if you want to understand what is happening dun sa inyong system. Okay, and next meeting, we're going to discuss damped oscillations. And we're going to consider itong mga phase plot nito to describe what is happening to the system. Okay? So, from today until Thursday, try nyo intindihin itong phase diagram. If you have questions, just write them down. Okay, kasi sa next meeting, gagamitin natin itong concept ng phase diagram, okay, to describe yung motion ng harmonic oscillator na mayroong damping, na may damping. Okay, and na mayroong driving forces. Okay.